right, today, kids, we are going to talk about topic 10.5, constant speed. And you will want to pause the video, take out a piece of paper, and open your book to pages 264 and 265. So pause the video and open up right now. All right, now, before we get started on the book information presented by Pearson Realize, I'd like to give you some background information. Constant speed means that a given speed will stay the same over time. Okay, so that's an important concept related to constant speed, and that is that you are staying the same speed over a certain length of time. Okay? Another important concept is that constant speed is a relationship between your distance you travel, the rate you're traveling at, and the time you spend traveling. Okay? So that's important to understand as well. And then the third concept is that the formula of D equals R times X, or X times, the formula D equals R times T is the formula used to explain and work with constant speed. Okay? So those three concepts are very important related to constant speed. Now let's take a look at the formula. Okay? The formula D equals R times T, the D represents distance, the rate is represented by R, and the time is represented by T. And what you want to do is when you're solving constant speed problems, you want to get in the habit of plugging in these variables or these amounts, okay, using substitution. So for example, the distance you travel, D, is based on the rate you are traveling at and the time you spend going at that rate. Okay? A good example problem would be this down here. If you travel 220 miles, it basically means that you have been going at a speed of 55 miles per hour for a total of 4 hours. And when we look at this formula, oftentimes we will say to ourselves, okay, what is our speed? Our speed is 55 miles per hour. How long are we going to go for that speed? We're going to go for 4 hours. How far will we get? We will get 220 miles. Okay? And so our constant speed is then 55 miles per hour, and we know that it's 55 miles per hour because we traveled 4 hours and we made it 220 miles. Right? Now, if you haven't watched the Fox video, I recommend that you watch the Fox video. But a quick rundown of what's in your book. Constant speed, and they ask, how are distance, rate, and time related? Leilani is flying from Los Angeles to Honolulu. If the flight travels at a constant speed for 4 hours and covers 1,716 miles, what is the constant speed of the airplane? Well, in this case, what we know is we know the time and the distance that they travel. Now, the book also explains what a formula is. And a formula is a rule that uses symbols to relate quantities. The formula D equals R times T relates distance, rate, and time. Rate in this formula means speed. Okay? Now, the book then goes on to show you the steps for determining the constant speed of the airplane. Okay? And so in this case, you can see where we use the formula, and what we do is we use substitution to get the variables. Okay? And so we know that the distance is 1,716 miles, and we know that the time is 4 hours. What we don't know is the rate of travel. You can use the properties of equality and inverse relationships to get the unknown variable alone on one side of the equation. So in other words, we want to divide both sides by 4 hours, which we would then do, okay? And then simplify each side, and we would come up with our constant speed of 429 miles per hour. All right? Now, I'm going to go over a few simple rules for figuring out the constant speed and for determining whether the time or the rate or the distance is a certain amount, okay? So here are some important rules that just kind of simplify what they explain in the book, okay? Here are some rules to help you determine either the distance, the rate, or the time, okay? If you know the distance and the time, but want to find the rate, what operation would you use? What operation? Okay? What do you think? Alright? Well, in this case, what you know is you know your distance and you know your time. The unknown is the rate. Well, again, if this equation is based on multiplication and you know what this amount is, but you don't know what this amount is, you would use the inverse operation, which is division. So if you know the distance and the time, but want to find the rate, you would use division. Okay? How about our next one? If you know the distance and the rate, but you don't know the time, what operation would you use? Well, again, in this example, you know this amount, and you know this amount, and you know in order to get this amount, you have to use multiplication. So in order to undo multiplying, you would use the inverse, which is division. So again, if you want to find the time when you know the rate and the distance, you would use the operation of division. And this is kind of, at this point, kids begin to realize why you would use substitution and you would plug in for your variables. Now the question is, if you know the rate and you know the time, but want to find the distance, what operation would you use? So in this case, you know the rate, you know the time, you don't know the distance, what operation would you use? Okay? And the operation, of course, would be to just follow through with the formula, which means you would multiply. Okay? So you might want to record these rules in your notebook so that you remember them, because they'll be very, very helpful to you. All right? So let's look at our book on page 265, and why don't you pause the video and see if you can solve these three problems. So why don't you pause the video and see if you can solve those three problems. Okay, let's check out your answers and see how you did. All right, let's look at problem number 1. You have a table right here which gives you your time, your rate, and your distance, and it then gives you the missing amounts for each situation. Okay? So in situation, they want to know the rate of the vehicle in trip A. So here's trip A, and the unknown is the rate? This is the unknown. Well, if we take our distance and we plug it in, and we say we've determined that, and we know we traveled for 18 hours, the unknown is our rate, okay? So what we would want to do is we would want to divide in order to find that answer. And if we divide, we see that our answer is 433 miles per hour, because what we do is we divide our distance by the time, which is the process of inverse operations in order to find the unknown. All right? Let's take a look at problem number 2. Excuse me. Time traveled in trip B. Well, if you look at trip B, you will see that what we don't know is the time. So we know that we had a rate or a speed of 80 miles per hour. We went a distance of 576 miles. What we don't know is the time. That's the big question. Well, in this case, our answer is going to be 7 2/10 of an hour, because in order to figure out the unknown, we're going to use the inverse operation, and we are going to divide 576 by 80. All right? Let's see how we did on problem number 3. Check your work with this one. The distance traveled in trip C. Well, we know that we are going to spend 12 hours traveling. We're going to go at a rate of 8 miles per hour, and we don't know the distance we will travel. So in this case, we know that we have a rate of 8 miles per hour, and we're going to travel that speed or rate for 12 hours. So we would simply multiply, and we would get an answer of 96 miles, because we multiplied 12 times 8. All right. Okay, in your book, take a look at these problems, 6, 7, 8, and 9. Pause the video and see if you can come up with the answer to those problems. Okay, here we go. Let's see how you did here. Again, remember that our formula for this situation, these situations, distance equals rate times time. And so if we know how to plug those in, we can figure out for the unknown. All right? Now, the answer to number 6 is, the answer for number 6 is 6 miles per hour. And the way we figured that out was we know the distance and the time. We know the distance and the time, which means you are finding the rate, which means you divide. You use the inverse operation. Okay, the answer for number 7 is 71 miles per hour. And the way you solve this one is you know the distance and the time, okay? You know your distance and you know your time. You are finding the rate, so you want to divide. Again, it's an example of saying, okay, you know your distance, 568. You know your time. You don't know your rate, so you would use the inverse operation to figure out that unknown. All right? Okay, number 8. Number 8, our answer is 40 seconds. And again, in this case, what we know is we know our distance, which is 120 centimeters. We know our rate, 3 centimeters per second. What we don't know is our time. So we would use the inverse operation and divide 120 by 3, and that is how we come up with our answer of 40 seconds. So you know the distance, you know the rate, and you are finding the time, so you divide. Alright? And then our last question that they ask, number 9. You know the rate is 56 miles per day. The time is 47 days. So we want to find the distance. And so in this case, you know the rate and you know the time. You want to find the distance. So in order to find our distance, we use the formula of rate times time. And if we plug in those amounts, we can see that we have a rate which is 56 miles per day times 47 days. And if we multiply that out, we get a distance of 2,632. Alrighty, hopefully this video helped you understand what was covered in class, or if you were absent, you might want to watch the Fox video if you haven't watched that yet.